Hi everyone, and welcome back to a new video on IB Math. In today's lesson we will be studying Poisson distribution, which is a topic in the IB Math AI high level. First we'll clarify what this distribution is and when to use it, and after that we will do a full example on it step by step to understand it very well. And of course we'll show the solution step by step in the GDC. So first, what is Poisson distribution? It's a discrete probability distribution that models events that happen at a constant average rate or mean rate in a fixed interval of time or space. Now, fixed interval of time could be like this: modeling number of cars arrive in a road, let's say per hour, per day, per week, and so on. Or like here in our example, average number of emails received per hour. So you always have this word per, like average in a unit of time. Or it could be unit of space, like let's say number of people living per square kilometer, for example. This is the notation for Poisson distribution, where this letter here, lambda, is the parameter of the Poisson distribution, or it's the mean in the distribution. In our example, since we have a mean or an average rate of 5 emails per hour, then lambda will be 5. Here, as you see, x is number of emails received in 1 hour. So x belongs to Poisson distribution with an average of 5 per hour. Now, something very important here. In any Poisson distribution, x, the random variable x, takes values from 0, 1, 2, all up to infinity. So here, true that we say 5 emails per hour, but this is on average. We have a probability to receive 0 emails per hour in some hours, or 1 email, or 2, or 3, or it could be 5, 10, even more. It could be, let's say, 100 emails per hour, but of course that then will be very, very, very unlikely, so that we can ignore that probability for very large numbers, as we'll see later with this and questions B and C. This chart here is not a part of the question. I added this to illustrate probabilities and the distribution better. So here, in question A, we need to find the probability of receiving exactly 3 emails in the next hour, in 1 hour. So we need to calculate the probability of x equals exactly 3. Here, since we have equal, we will use what we call Poisson PDF in the calculator, as we'll see now. First we add calculator, then menu, number 5 probability, and then distributions. We scroll down to Poisson PDF as you see here. Later, of course, we'll use also Poisson CDF in this question. So now we choose this. Lambda, or the mean in our example here, is 5, and x, as you see, 3. So here we have 5, and then here we have 3. Then, as you see, the probability is 0.140. So 0.140. The probability to receive 3 emails would be, in 1 hour, 0.14. Now, notice that here in this chart, here we have the values of x. We have the values of x. And these here, the vertical axis, represents the probabilities. So as you see, what we just calculated now is the probability of x equals 3, which is what we got, 0.14, as you see in the GDC. So here, as you see, these are the values that x can take. 0, 1, 2, 3, all up to infinity, not only up to 40. But as you see, when x becomes a little bit large, then the probabilities will be very, very, very small, so that you can completely ignore them. They don't affect the answer. This will help us in questions B and C. Now here, as you see, in question B, we need to find the probability that we receive at most 4 emails in 1 hour. Now, when we say at most 4 emails, it means 4 or less, like 4, 3, 2, 1, or even 0. Could be 0 emails. So the very lowest number will be 0. Here, since we have inequality, first we write it like this. We need to calculate the probability of x smaller than or equal to 4. So 4 or less up to 0. Here we use we use Poisson CDF. So distribution, Poisson CDF here. Lambda is 5. Here the lower bound will be the least amount. In our case, since we have 4 emails or fewer up to 0, then the lowest number will be 0. And the upper bound or the maximum number of emails would be 4. Here, as you see, it will be 0.440 to 3 significant figures. Now here, what we calculated the probabilities of from 4 and less up to 0. So we calculated these probabilities combined. Here for the 4, which is nearly 0.18, and for the 3, and for the 2, and for the 1, combined and added. Now here in question C. Question C is very important. Here, find the probability of receiving more than 7 emails. So here we have the probability of x more than 7, but not including 7 itself. When we say more than 7 emails, it means a minimum of 8 emails, 8 or more. So this is equivalent to saying that x will be greater than or equal to 8. Now here we use also Poisson CDF. As you see, lambda will be the same 5. Here the lower bound will be 8 because we have 8 or less. Now here, since we don't have an upper bound, here, then it will be infinity. As you see, x goes to infinity. But since we cannot input very large numbers in calculator, we put randomly a large number. Like let's say 100. 100 would be very large. Because as you see, even here, when the values get even like bigger than 12 or 13, they will be nearly 0. Not to mention that when you go to 100, they will be very, very small. So here, randomly as an upper number, we can put 100. Then as you see, the probability will be 0.133 to 3 significant figures. Now, in case, for example, you have a question like this, receiving, let's say, between 3 emails and 8, here, of course, you put the lower bound 3 and the upper bound is 8. So this is all about Poisson distribution and how we can use it and calculate it in the calculator. I hope that you have found this video helpful. Please hit the like button and consider subscribing for more videos. Thank you for watching.